Okay, trying the video again. Everyone, work on number 17. Try to do it. Pause the video. You have paused the video and you are now back after doing this problem. And guess what? You could have done a U substitution. Ha 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 ha. If you make U everything under that root, the derivative happens to be the numerator times a constant multiple. So the lesson learned here is always try U sub first. Keep an eye out for it. I'm replacing my x dx with 1/2 du. From there, I have u to the negative 1/2 and I'm integrating. So u to the add 1 to the exponent, multiply by reciprocal. Don't forget there's a 1/2 plus c, and then put that u back in, which is going to give us the square root of x squared plus 7, no, minus 7 plus c. Woohoo! So again, U substitution, always be on the lookout. Now, with this problem, you're going to need to complete the square. I'm going to talk you through completing the square. And I'm doing this video faster because, yeah, I forgot to push record. So, with completing the square, I am going to take that t squared minus 6t plus 13, but I'm going to actually set that plus 13 over to the side. This problem is kind because my leading coefficient is 1. So when I go to complete the square, I need to find just the right number to add so that that trio of terms factors into a quantity squared. Because I need, for trig substitution, to have a function squared plus or minus a constant squared. When I complete the square, I compensate of my addition of a number by subtracting a number. With my variable being t, I'm going to set up, I've got an entire preparation ready to go for completing the square. And we're going to do a quick completing the square. Make sure you're paying attention. Take the middle term, divide it by 2. Take that number and square it. Done. You just completed the square. Make sure you notice that because it was a negative 6, you get negative here. But whether this is positive or negative, you're squaring it to make it positive every single time. Then what I don't have yet is negative 9 plus 13, which is 4. And now I'm going to rewrite my integral. Now, if you want to try this problem on your own, before I do it, pause the video. Here I go. I see a function being squared and a number being squared, and it is addition. That means I'm going to use tangent theta. The function being squared is t minus 3. The number being squared is 2. I need to take my derivative. I'm going to make my right triangle. With tangent, we have opposite over adjacent, Pythagorean theorem, and we're ready to go. And I just realized I wrote a dx where I should have a dt. I will replace dt. And if I want to make my life a little bit easier, that square root divided by 2 is equal to the function secant. Or you can directly substitute into your t minus 3 a 2 tan theta, and perhaps see that you have under your square root a 4 tangent squared plus 4, which is then going to give you 2 times secant squared. Or under the square root, a 4 times secant squared, which then gets square rooted to 2 secant theta. Then my dt. I'm left with the integral of secant theta. And you want to have that memorized. It's the natural log of secant theta plus tangent theta. And I can go back to my triangle and find what secant and tangent are. And actually, I have them right here. There's secant, there's tangent. And now for the third and last problem. You want to notice that this is not just a rational function. You may want to begin by rewriting this as a square root cubed in your denominator. Under that square root, we have a polynomial, and I'm going to write that polynomial in descending order, negative 4x squared plus 4x plus 3. And I need to complete the square again. But this time I have a number multiplied in front of the x squared. I have a coefficient that is not 1. So what I'm going to need to do is factor it to the side. When I factor it to the side, I'm dividing by it. And I've got to make sure I divide each and every term. Now, since I'm going to prep for completing the square, I'm going to bring my minus 3/4 over to the side. And I need to find the right number to add, but compensate and subtract. These three terms factor to some parentheses squared. The variable is x. So again, I'm prepping this. And complete the square. Here we go. Coefficient, middle coefficient is negative 1. Divide by 2 and square it. Kindly enough, this is minus 1. Now I'm going to distribute my negative 4 back through, and that's going to change my subtraction order, and I'm going to have 4 minus 4. Now, I can make my life a little bit easier because this is under a square root, and having a 4 as a common factor, maybe I didn't really want to distribute that through. But let me tell you that that negative sign must be distributed through, or you might read the wrong trig function. So I'm going to have that 4 aside because that saves me a little bit of pain later. Okay, now let's go back to the integral and put that in. All right. For the 4, I'm going to square root it and then cube it to get 1/8. And now I'm finally ready to begin my trig substitution. Due to the order of subtraction, I want to use sine theta. The function being squared is x minus 1/2. The number being squared is 1. I need to take the derivative. And it would help if I made a right triangle. My sine is equal to opposite side over hypotenuse, Pythagorean theorem. And now I have the root side divided by 1 if I want to take a shortcut, is equal to the adjacent over the hypotenuse, that is cosine. So I have my entire square root in the denominator will be replaced with cosine. My dx will be replaced with cosine theta d theta, but I've got to isolate my x to deal with that x squared. I have 1/8 x squared, and then my substitution and my other substitution. And finally, my x is equal to sine theta plus 1/2. Okay, now it's time for some algebra. Oh, I almost forgot something. That was cubed. I did deal properly with the 4. I did its square root and then cubed it to get the 1/8. Okay, now I have a denominator of cosine squared once I cancel one of those away. For my numerator, I need to expand, but be careful, I don't just distribute my exponent over addition. Now, my denominator does not have addition subtraction, so I am able to distribute its division. I have sine squared over cosine squared plus sine over cosine squared plus 1/4 over cosine squared. And you may want to stop the video and see if you can complete this integration on your own. Sine squared over cosine squared is tangent squared. I will be able to integrate tangent squared if I first convert it to secant squared minus 1 using the Pythagorean identity. This can be integrated by either doing a u substitution of cosine, or you might realize that what you have there is sine over cosine, which is tangent, times 1 over cosine, which is secant, and you might recognize that. That is the answer to a derivative. And then I have a 1/4 times, and cosine's reciprocal is secant, and it is being squared. I'm going to bring together secant squared theta plus 1/4 secant squared theta while I'm integrating. That gives me 5/4 secant squared theta. The integral of secant squared is tangent. I have my minus 1, integrates to theta. Then I have tangent times secant is the result of the derivative of secant. And I already dealt with that last piece, plus c. And now I just need to convert back. I'm going to grab this and move it. Try again. No, don't drop it, don't drop it. Keep going, keep going, keep going, keep going. Okay. One-eighth times 5/4 multiplied by tangent theta. My tangent theta is opposite over adjacent. Minus theta. I go back to my original substitution choice. Theta is the inverse sine of x minus 1/2. And then finally plus secant theta. And secant is hypotenuse over adjacent. Woo! That was a hard one. I would not give this to you on a test, but you needed to see some tougher integration. Congratulations, you made it through it.